We live in the world where AI can write code, build apps, and automate workflows. So it's natural to ask, does computer science still matters? The answer is more than ever. Because tools changes, frameworks change, language evolves, but fundamental principles of computation remains constant. This series isn't about chasing trends, it's about understanding the architecture of thinking that powers modern technology. Welcome to Computer Science. Many people think computer science is just writing codes, but computer science is actually a study of how machine thinks, how system run, how we build reliable software. Coding is just the surface. Computer science is a mental framework behind every digital tool. If you understand the framework, you're not just using tools, you're guiding them. To make computer science clear and structured, we divide it into three pillars: computation, systems, software creation. Think of this as the architecture for modern computing. Each pillar represents a different dimension of understanding: how problems are solved, how machines operate, how software is built. Together, they form the complete engineering mindset. The first pillar in computation, learning to think like machine. Here we study algorithms and data structures, how information is organized and manipulated, complexity analysis, how effective solutions scale, automata and logic, how decisions are structured. These pillars train your brain to move from guessing to systematic problem solving. It's where intuition becomes engineering. Why computation matters. Computation teaches you efficiency, structure, and limits. Instead of brute force thinking, you learn optimal thinking. Instead of trial and error, you gain reasoning patterns. This is what separates someone who writes code from someone who designs solutions. The second pillar is systems, understanding how computers actually run. This includes computer architecture, how hardware executes instructions, operating systems, how resources are managed, networking and distributed systems, how machines communicate. Most developers use systems, engineers understand them, and that understanding gives you power, performance awareness, debugging insights, and system level thinking. Why system matters. System knowledge reveals what happens beneath the interface. It explains why program slows down, why memory fails, why network behaves unpredictably. When you understand systems, you don't just react to problems, you anticipate them. The third pillar is software creation, turning ideas into real systems. Here we study programming paradigms, different ways of structuring logics, databases, organizing information at scale, software engineering, building maintainable, collaborative systems. The pillar transform the theory into tools people can use. Why creation matters. Software creation is about sustainability, clean architecture, readability, and reliable deployment. It's the difference between code that works today and system that lasts for years. We are entering an era where AI accelerates development, but acceleration without understanding is fragile. AI can generate solutions, But computer science tells you which solutions are correct, efficient, and scalable. Understanding guides automation, and that makes fundamental more valuable, not less. Master computation, you learn to think clearly, master systems, you're understanding how machine behaves, master creation, you build intentionally. Together these pillars from the backbone of modern engineering. Computer science is not about memorizing syntax, it's about building engineering mindset that lasts across technologies. When you understand the pillars, you don't chase trends. You shape the future. Welcome to computer science, and this is the only the beginning of new series where we unfold these pillars one by one and get in-depth knowledge on how computer science works. And since the new era of vibe coding is a dominating factor among all the developers and developers who are experienced for many years are also indulging themselves in vibe coding, and this is a wave of technology, so we cannot suppress this, but rather we should be enhancing them. And this is the right course if you're getting into vibe coding, because it gathers all the computer science fundamentals you need to get before starting to vibe code, because if you are aware of fundamentals of computer science, then your efficiency and your diligence increase rapidly with your own computer science knowledge. So this series also welcomes the vibe coders to learn the foundations, pillars of computer science. So thank you, and stay tuned for upcoming videos.